My name is Ben. I'm from Alluxio. I'm the founding member and also the VP of open source in Alluxio. Sorry, can I? Yeah, so before we start, how many of you are in this room, you're using GPUs or you're directly using machine training workloads? I think about like 1/3 of people. Okay, so I think,
This right here?
oh, okay. Yeah, so during the training process, you may know that a lot of the models these days, they are really data hungry. So we see more and more either people in our customers or the people in the field, they are talking about, hey, we're having these models, we're training these models, and we need to feed them tons of data, right? And it's not necessarily always the case this data is easy for the applications, GPU application to consume. So this is the talk we're going to talk about today, sharing our observations and our solutions. So first of all, what is Alluxio? It is an open source project, and we were actually we were a research project before from UC Berkeley AMP lab. And it used to be the case where you can think the sister project for the Apache Spark project. So Alluxio is built for machine learning and data analytics kind of workloads. And in the ecosystem where we are is in between these applications, compute applications, and the storage. So what we provide, you can think it's a data platform or data access layer that can help you to load the data closer to these applications and manage the data so that you have this only the hot data or the data you needed in this the faster memory or faster media, or it's in a closer storage capacity. So underneath Alluxio, you can link your storage source either from AWS S3 or your own data warehouse in Hadoop, in HDFS, or some other cloud storage into this Alluxio virtual storage. Okay, for the context of this particular conference, I want to focus more on the training, on the machine learning side. So essentially what we see a lot in the field is more and more people, they are more and more organizations, they're hosting their data in a centralized data lake, for example, AWS S3. They use this as a company-wide data lake. So all the offices, all the different teams, they push data to the S3. But due to the latest, you may know, like everyone is fighting for GPUs. So a lot of times we were told, hey, we just use the GPUs whenever we get it, wherever we get it. For example, this can be in a different region from where they store the data, or even from a different cloud, or it's even in their own data warehouse, because these days, like, people just cannot afford retiring GPUs. So this becomes more and more common problem. This morning I had a call with a customer there. Basically, they have their own data in GCS, in GCP, but they want to use GPUs on AWS because that's the only GPU resource they can find right now for their own cases. Okay, so a common solution we see is, hey, moving data around is not fun, especially moving data out from the cloud is not fun. First, you get a performance possibly get a performance penalty, depends on your pipe between your GPU clusters with the storage. And second, moving data out from this cloud storage also comes with cost, which is called egress cost. So that becomes a problem, and a lot of the common practice we see, if you read the PyTorch, any tutorial on PyTorch or this application, they may tell you the recommendation way for you to train this data is to copy the data to the local. So oftentimes you see a solution like this, using some command or some tool, you sync your data from S3 to a NAS or some shared storage. And then you can run your own tools to distribute the data, the training data, to all these GPU machines so they can see the data almost like a local data. What we're providing here is a system. We call this Alluxio virtual storage, virtual Alluxio storage that can be shared across different GPU nodes. And inside of Alluxio, we're leveraging this typically spare You can Alluxio is a software-defined storage, so you can run this whenever you want to run this. And typically, we see a lot of users are running this in their GPU machines to leverage their SSDs, because we see quite often these SSD or this fast storage on these GPU machines are not fully utilized. And then we can leverage this resource, put them together. We have our own storage engine, our own data loading engine, and putting this together as a virtual storage for the applications. Applications may see this, if it is through our POSIX API, you may see this virtual distributed storage as a local storage, as a local folder. So they can continue train the data just like they're reading data from local, but in the back, it's from this distributed service. And behind the scene, Alluxio can be also, you can also mount different storage source into this virtual storage engine so that your applications see, logically, they can see all the files you mount from S3 to this virtual storage. But we only load the data you need for training into this storage engine, and only once it's loaded, another application, when another application or some other nodes need the same data, we can serve you. So this first removes the necessity to move data. First, copy this into a shared storage. And second, we can manage this data in an automatic way, in a transparent way to the applications and to the users. So it's super convenient. And in this way, you get the benefits by both performance, removing the unnecessary egress cost, and also removing the cost on ops to manually managing the data. Like, for example, if you still running data script to copying data around, and that can just remove the purging or cleaning or this type of cost. Okay, I'm just showing some tests to show you why this is the case. We think this can help the performance. We're running the ResNet 50 in the AWS. And we see, in the naive way, without having Alluxio there, if you're just using S3 Fuse, this is a common way to translate S3 as expose S3 as a local storage. And 80% of the time you spend in data loading, the data loader part. This is from a tensor board. And the GPU utilization is super low. It's 16%, say 17%, because you spend too much time waiting for I/O. Having the Alluxio solution here, and we can successfully reduce the data loader to occupy only 1% of time. And subsequently, you get a GPU utilization as high as 93%. So which is, that means the GPU is fully utilized. You don't have to spend time waiting for the data. Okay? So if you want to have just one takeaway from my talk, with a solution like Alluxio, you can put Alluxio in place closer to your GPUs, so you can spin up your GPUs whenever these are available, to have your GPUs connected directly to your data lake, to your S3 or to your other data lake solutions, just like these GPUs having their local storage. Okay? So we have a booth outside. If you want to know more, talk with us in the booth and scan the QR code for if you want to have a performance and GPU utilization benchmark. Thank you. So the question is, how much is the cost for the? How do you avoid the egress cost? Because you need to bring the training data to the GPU on-prem in the case of. Yes. There's a magic we can do. Like you have to move the data once, right? But once the data is moved into Alluxio virtual storage layer, then before the data is evicted, hopefully not, right? Then you always get a cache hit from this Alluxio layer, and you don't need to go to you don't need to go to the cloud storage again. Yeah. Time for one more question from the audience. Okay, cool. Thank you for your attendance.